This is you can all hear me okay? Yeah? Okay. As it says, this is a short talk about looking at web vulnerabilities and using a very useful piece of software to find them. I work for a company called Human State. My name is Lee. We're kind of a service platform. We have two main platforms. We have a crowdfunding platform, which is called Give and Gain, and that is about 80–90% publicly accessible. And we have another platform which is rental management, and it's less than 1% publicly accessible. And we've gone through the process of modernizing these platforms. We've moved from a CGI, ModPerl code base to Modulicious, etc. So when I first arrived, I was doing a lot of work to find some of the typical vulnerabilities that you might find in an older app. And I haven't made the assumption that these vulnerabilities don't exist in the modern versions of these apps, so we continue to scan our apps for vulnerabilities. I think the answer to this is quite obvious. If you have a public-facing app, then really you should try and make sure it's pretty secure. If it's an internal-only app, you should probably still do that. And even if it's kind of a single, your own private thing that nobody else has access to, there's maybe value in that because you upload that to GitHub and then suddenly it's in somebody else's production environment. So, how often should you scan? Bearing in mind none of you are on the video feed, has anybody never actually scanned their public-facing app for vulnerabilities? Okay, that's not surprising. I mean, I suggest that the first thing you do when you get back on Monday is you look into this, because you might be pleasantly surprised or unpleasantly horrified about what there is there. We get scanned externally once a year, so we pay a fair amount of money to get an external company to do it for us. But we also self-scan at least twice a year. And obviously, if we do any big refactoring, big features, we do another scan. I say automating this would be the end goal, but to do a comprehensive scan on our app can take several hours because it has to go and find everything in there and it's running hundreds of thousands of tests on each page, so it can take a very long time. So just to briefly cover what we're actually scanning for, there was a short lightning talk on this that touched on this yesterday. I'll just go into a bit of detail about what we're looking for. This is from the OWASP Top 10, which was updated 2 years ago. They update this every 3 or 4 years, and generally things just move around. There's not much that gets in and goes out because these are all the main security holes. So injection is obviously SQL injection, OS command injection. Broken auth is things like permitting weak passwords, allowing brute force attacks. Sensitive data would be not using HTTPS or using weak encryption algorithms. This is a new one that came in for 2017, Xml External Entities. And the easiest way to explain that is basically that if somebody uploads XML and it references their random, you've got a DOS attack. If you're thinking, oh, I'm not using XML, I'm using JSON, well, JSON schema has started to use external references, so think about that. Broken access control is users can change the URLs and they can access data they shouldn't be able to access, primary keys and roots, things like that. Security misconfiguration, that's things like you have unnecessary ports open or using the out-of-the-box default accounts. Cross-site scripting is the classic one, I'm sure we all know that, and that's a massive game of whack-a-mole in my experience. Insecure deserialization, sending stuff out, bringing it back and it's not signed, you're not checking, that kind of thing. Using components with known vulnerabilities, so you're not keeping stuff up to date, you're not looking at CVEs, you're not looking for patches, you're not keeping those up to date. And this is the second one that made it into the top 10 because there's been a number of high-profile security breaches over the past couple of years, and the company said, oh, we didn't know we were hacked until 6 months after we were hacked. And if you do decent logging and monitoring, hopefully you should pick up on that quite quickly. So what we use is a proprietary piece of software, well, a non-open source piece of software called Burp Scanner. And It costs, yeah, I think the price is actually very reasonable for what it does. It's 300 euros per single license per year. And it's extremely comprehensive and configurable. I use about 10% of it. It's updated frequently. Hopefully when I open it soon, it doesn't ask to update it. I say it's the industry standard because when we've been externally scanned, the reports we get back are the reports that it generates. So it seems to be quite a commonly used tool. Okay, yeah, there we go. I have no affiliation with them. I just think it's actually a very good product. And there are open source alternatives that I'm going to try and touch on later on. Okay, live demo time. So what I've done is I've created a very small modulicious light app that has some vulnerabilities that the Burp Scanner would generally find. I'll make them a bit smaller. And what I'll do is open it up. Yeah, there's this very strange thing when you open it on a low resolution display. And it has all these options to create projects and create configurations. Generally, I just start fresh when I do it. And use the defaults. The defaults are very sensible. Can you all see that okay? As I say, I don't know, most of the tabs here, I don't use them. And what we have to do when we start it up is we have to make sure the proxy intercept is off, because by default it's expecting you to intercept requests. And as I say, I've created this very simple web app. Let me find my terminal. So it's a little app, so I called it a little app. And it's just a single page with so it has one page which says login, and it has a login form with the username and a password. And when you log in, it says hello. So just about as simple as you can get for a dynamic site. And what we have to do is we have to set up a proxy. Burp has its own proxy, so it can obviously intercept the requests and stuff things in there. So that's proxy. So, which is generally 127 and then port 8080. Okay. I go back here. So what it will do is it's now listening on that proxy, and it has this target tab, which you can, obviously you don't want it to scan the entire internet, so you can define a target URL and target routes and target ports. But it can run in passive mode. So if we log in, again you get the security, the SSL, whoops. So if we should see, so it's detected the URLs that it's found in where I've gone, and then you can add them to the scope. And you can define the scope here. You can add URLs, ports. It supports regular expressions. And what it will do is, well, what you can do is you can tell it to spider a host, and it will go out and find all the URLs. Now, if you're using dynamic pages, you're using AJAX, using callbacks, using APIs, it's a bit more difficult to find those. So generally, if you're doing that, you probably want to browse the site manually and use it in passive mode, and it will then intercept those HTTP requests and add them to the scope. I haven't even done a scan yet, and it's found issues. It's saying there's a problem with the SSL cert. We're using get method to send the password, autocomplete. these are all, well, I'd say that should be a post rather than a get, but the rest are not, they're not things that are going to potentially bring down your app on the back end. You can rescan actively, and you can put things in the scope again and out of scope. And if we watch the logs, you can see that it's, there we go, it's trying to throw stuff in there that's looking for exploits. So that'll be a cross-site scripting. The default out of the box, I think it used 10 threads, so if your app is a little bit slower and not capable to support that, you can adjust it.
Did your app have JavaScript?
It didn't, but it's trying to do a cross-site scripting there.
It's guessing that.
Yeah, it is. Like I say, it's kind of whack-a-mole with cross-site scripting. You think you can, oh, look at that, and I'll just put an exception, and actually it has a huge composite of strings that it will throw in there. And often you will look at it and think, I have no idea how that can be an SQL injection or a cross-site scripting attack, and it is. So yeah, well, I fixed those problems. And what we can do is we can run it again. So if I clear these issues, delete issue, there we go. Should be able to select them all and delete them. There we go, delete selected issues, yes. And then run an active scan again. Okay, it's running. And that looks good. Of course, code changes, we add new features, we add new bugs. So I'll scan it again. Whoops, passively scanned rather than actively scanned. See, it's running away there. Okay, try that again. I think because I hit passive scan rather than active scan, it did a different thing. So let's try and hit the right thing this time, actively scan. Okay. Right, what I'm going to do is quit that and start it again. Usually once you clear out the issues, it will do the entire scan again. It doesn't cache the fact that it found an issue and ignore that the next time. Scope, nope, scanner, target, proxy, intercept off, sitemap. I think I know what this might be actually. Because it's not running. Okay, so we will actively scan this host. And what I'm going to do, add it to the scope. Whoops. Okay, scanner. What I'm looking for here is, okay, it's not there. I think it's because what normally happens is if it finds a form, it will pop up a box. I found a form, you need to give me the params, so you can put in this case, the username, the password. And what I have actually in this little Mojo app is I'm not using bind params to call the database queries, so it finds the SQL injection. And that comes up in a big red flag. Any issues that are generally in the OWASP top 10 will be red. And what you can then do is every issue that it finds, it will give you the request and the response headers. And this is very useful because, as I said, it really, really does try to stuff some very, very obscure strings into there. The SQL, obviously, it doesn't run things like drop database, Bobby tables. Generally it runs, it'll try to run a sleep, and then it compares response times, but it does other things. Obviously run it against a dev VM, not a staging or a prod. And it really does try its hardest to bring down your, well, not bring down your app, but find the holes in your app. And you can export all of these issues to a HTML file, PDF file, and like I say, it has the request and the response headers. When it dumps out the HTML in the response, it highlights where it found the vulnerability. If it's a cross-site scripting attack, it will show you what went in and what came out. That's a good point. No, it was off. But it doesn't matter. I mean, you see the issue there as SQL injection, and there's the next one I fixed it, but I don't think it's necessary to run that. So what I will do now is go back to the presentation. Okay. Not that one. That one. Okay, so yeah, I mentioned there are some open source alternatives. This is a list. I'm going to go through each one in turn. This is actually by OWASP, the Z-Attack proxy project, and as you can see, it looks quite similar to Burp Scanner. It's a nice Java app. It's very configurable as well. It's trivial to install and run. It doesn't seem as comprehensive. I guess it's just looking for the OWASP top 10, all those ones. But I would definitely check this out. This one will find SQL injection and those serious ones quite quickly. There's W3F or WAF. I don't know how to pronounce it, but it's a Python. I say it has a GUI, but the dependencies to get the GUI running are all massively out of date, so I couldn't get the GUI running. But the console works fine, and this is easily scriptable, so this might be a way to automate on a CI server or something. And that's the output of it. It puts everything to a log file. It's got send stuff to the terminal and the log file, and then you kind of have to post-process the log files afterwards to find, report on those things, but it seems pretty good. It found the SQL injection. That's kind of my benchmark of is the scanner actually any good? Does it find this very trivial SQL injection hole? Arachne, this is a Ruby one. Again, it seems quite good, but it didn't find the SQL injection out of the box, so maybe it needs some more configuration. But again, it seemed quite nice to use. This is Wapti, this is a project that is aiming to create an open source equivalent of Burp Scanner, and it's written in Go. I got it running quite quickly, but then it didn't do anything. They do say that it's a work in progress, I think, so maybe it's one to watch. It's quite young, I think 6-12 months. And there is one in Perl. This is actually, anybody heard of this one? Nikto? This has been around for a number of years. I'd say at least a decade, maybe 15. And I think it's on GitHub. The links are on the slides. It didn't find the SQL injection because maybe it needs more configuration out of the box, and it did seem to have some false positives. I'm saying false positives, but I'm comparing this to what Burp Scanner was finding. So this is something to bear in mind. That one scanner might find one thing, another thing. But yeah, I think that's worth a look as well. And I'm just about out of time. Does anybody have any questions? Max?
When you showed the Burp Scanner request and response pair, is there a way to export it like as an HRR or
Yeah, so
you can store it.
the question is, can you export the Burp Scanner's request or response headers, and then you can obviously, I guess, add that to a test or whatever, replay. Yeah, I believe you can. Certainly it exports it to the reports. I would say 99% sure it would. You can create a test case from it.
Do you have any experience automating the Burp stuff?
S-
Yeah.
yeah, yeah.
I don't want to just be the sitemap run it over and over again.
I think the question was, have I tried to automate this, and because of the issues with dynamic requests, Ajax, all that, is that possible? I haven't tried to automate Burp Scanner. I know that it has a lot of functionality to crawl APIs. It now supports, you can give it a Swagger spec and it will do that. I haven't looked into the dynamic thing. Generally what we do is we get externally scanned, they're looking at all the pages, Burp Scanner picks up on it, and then I will do that myself if I know we have this page that's doing some JavaScript calls.
Why pay somebody outside if all they're doing is Burp?
Why pay somebody outside if all they're doing is Burp? Because it's useful to get a second eyes that's outside the dev team to do this.
Burp first,
Do we do?
then pay them?
We do. I mean, the idea is we want many eyes looking at this, people that are more experienced using Burp Scanner that are scanning us, and we set up the staging environment and they look at it. And the last 2 runs have been clean, but as I say, things creep in, so it's a useful thing to do. I think Nick had a question.
Yeah, you use external scanner ones here. Which one do you use?
I would have to, which external scanning team do we use? I would have to look into that. We have used, I think, now 3 different ones, because again, it's useful to get different people looking at this. Nick?
First one was your little testing. Is that online as well? Is that useful?
So are the apps online? Yes, they are. They're in the GitHub repo.
And the second thing was just something that occurred to me, and I wouldn't need to do it, right? So if I started to run a bug bounty, I wouldn't need this order of to persuade my boss to buy it. But if we find 2 things, this will pay for itself.
Yeah, this is more than paid for itself. I mean, and I will twice a year. I will spend almost a week running this, looking at the issues, because I mean, a lot of these issues here are they will kill your company essentially. So the 300 euros per single license per year is nothing, absolutely nothing. Any more questions? Okay, thank you very much.